Thank you. Welcome, everybody. I will talk about the Computer Science Engineering master course at the university. So why should you get a master in our university? So first of all, as the statistics shows, the starting salaries of MSc graduates are much higher than compared to the BSc level diploma. In many cases, selection of work candidates at some big companies depends on the master diploma. And also, it is important that you can do your own effort to improve and deepen your knowledge. And also, it is important that you can choose lots of different specialization and you get more knowledge in a specific area. We think at the university that the science and education is going hand in hand. So we encourage our students to do research work in our research labs at the faculty. And it is also possible to do some cooperation with health-related applications, as you previously see, related to the infobionics. Also, when you get your master degree at your workplace, it will be you will be assigned more challenging and more interesting works. So not only writing some small piece of code years after years, but you can be involved into generating larger generating larger systems. Also, we think that the MSc studies are an entry level to further studies, and hopefully you can follow your studies as a doctoral student for a PhD degree in a scientific area. We also think that the BSc level diploma is an extension, MSc level diploma is an extension of the BSc level diploma. So the two together provides a normal full university diploma. The duration of the MSc studies is 4 semesters. All lectures are in English, so because English is the native language of informatics. And after graduation, if you have some successful scientific results, publications, these results can be used for entry-level PhD studies. What are the main cornerstones of our education here in the Pázmány? We think that the 4 fundamentals are computer science, which teach you the rigorous mathematical description of computations and provide the theory behind information technology. The next thing is the theory of algorithms, where you can learn the different algorithms which can solve different tasks, and you can be able to analyze the operation of these algorithms and decide whether they are appropriate for a given task. If you can create algorithms, you need some hardware to run these algorithms on, and to understand how the different newer and newer devices are on the market working, you need a strong background in electromagnetism and photonics, quantum and electrodynamics to understand how the physical devices in the processors and in other devices are working. So these are the basic building blocks to create hardware. And using these building blocks, if you learn electronics, hardware, and computer architectures, you can create complex systems which can be used to solve complex problems. So these 4 legs are the main cornerstones of our studies here. Here you can see some key fields from our faculty. First is the cellular wave computing, where we use some kind of analog processor arrays to do some processing. And the advantage of this technology is that it can provide us very high computational speed. Natural language processing and technology is also important for us because the interface to interact with computers and computer systems is changing, and there are lots of systems which can be controlled by voice. On the other hand, the large amount of textual information which is stored in large databases requires special tools to find relevant information. For example, if we have some medical databases with lots of results of examinations in a textual way, we need to know efficient techniques to find data and find relations between the data. Sensory robotics is another important part where you can learn how can you program robots and how can the robot sense the environment and contact with persons. Also, machine learning is important, and also this microelectronic system to create hardware system which can process and solve tasks in a given environment. And last but not least, the classical software engineering, where you can learn how to design algorithms and how to create software tools to solve specific problems. Here you can see some of the mandatory specializations which you can choose from. The first is the machine learning for data science, which is based on the current state-of-the-art deep learning neural networks and how can you apply these networks to solve specific problems. High-performance computational tools and architectures will teach you how can you use, for example, a graphics processor card to execute some computationally intensive algorithms at a high speed, and how can you efficiently use the available hardware resources to solve a given task. The last one is the software engineering, where you can get the skills of the latest techniques and methods of generating or writing software. Further possibilities are you can be involved in or intensive international relations. We have contact with Notre Dame, Leuven, Berkeley, to name a few. And also you need to do a compulsory internship, which you can do either at a multinational company such as General Electric, Morgan Stanley, and so on. But it is also possible to do this internship in small startup companies in Hungary, and also in the university, if you wish. Okay, here you can see some areas where we created different algorithms and solutions. For example, in UAV systems, where we should avoid collision with other planes, where we can generate an avoidance path which is provably safe. We created onboard hardware for processing the information on the board of the plane, and also a simulation, because in some cases the flight scenarios are hard to replicate. In the robotics field, some of our colleagues created some sensing measurement systems which will be able to measure the force on the tip of a robotic hand. And for example, the robotic hand can safely grasp glass. And also we have experience with many or kilo-processor chips, where each processing element of the chip is related to 1 pixel, and it provides us very high computing performance in an image processing field. And also we are involved in the next generation hardware, which can be, for example, spin wave based logic element, which will provide the next generation of devices, which can be used to create new processor, which has less power dissipation, for example. Thank you very much.